To factor this by the differences of squares, the first thing we have to do is to see if we can factor this by the GCF, which is the greatest common factor that can go into 400 and 144. So to find that number, I'm going to use my upside down cake method. So we have 400 and negative 144. So a number that can go into 400 and negative 144, I'm going to start with 4 because 4 can go to 400 100 times, and 4 can go into negative 144 negative 36 times. And I can break these two numbers down even more by another 4 because 100 divided by 4 is 25 and negative 36 divided by 4 is negative 9. And there's no number that can go to 25 and negative 9 evenly, so therefore my GCF for this problem is going to be 4 times 4, which is 16. And for the variables, you want to take out the smallest exponent for each one for the GCF. So for x, we have 7 and 3, so the smaller one is going to be to the third power. And then for the y, we have 6 and 12, so the smaller one is going to be 6. So now I'm going to take my binomial and divide it by the GCF, which is 16x to the third power and y to the 6. And when you divide, you subtract the exponents for the variables. So we have 400 divided by 16, that's 25. 7 minus 3 is 4, so it's x to the fourth power, and y is gone. For the next one, we have negative 144 divided by 16, which is negative 9. X is gone, 3 minus 3 is 0. And then for the y, it's 12 minus 6, which is 6. And the last step for factoring by GCF is put parentheses around it and put the GCF in front, 16x to the third, y to the 6. And now I can further factor this by the difference of squares because both 25 and 9 is a perfect square root, and 4 and 6, both exponents are even. So again, factoring means that you're unmultiplying. So just like earlier when we multiply, we use the table method. So when we're factoring, we can also use the table method to help us find the factors. So I know that I need to find two numbers that will multiply, give me 25 x to the fourth power, and then again my last term again multiply will give me negative 9y to the sixth power. So what two numbers, same number, will multiply give you 25? Well, that's going to be 5 times 5. And for the x to the fourth, I know that x squared times x squared is going to give me x to the fourth because my exponents, I add them when I multiply. And again, these two numbers must be the same because I want to make sure that the middle terms cancel out when I combine the like terms. So for the next one, what number multiplied by itself is going to give you negative 9? Well, that will be 3. So because it's negative, so one has to be a positive 3 and the other one has to be a negative 3. And y to the third power times y to the third power is going to give you y to the 6. And as you can see, if we continue multiply this out, the middle term is going to give us positive 15 x squared y to the third, and then negative 15 x squared y to the third. And again, as from the original problem, you see there's no middle term because the middle term cancels out, it becomes a 0. So therefore, the factors for 25x to the fourth minus 9y to the sixth power are the numbers on top of the table, right here and right here. So now I can write my final answer. So I have 16x to the third, y to the sixth, times, we have 5x squared, and then positive 3y to the third power, and then negative 3y to the third power. And that's the final answer for this problem.